Okay, so what exactly is a limit? Well, we have some condition in this function, right? Well, we have some condition. Well, the condition is that below, as my denominator, if I had to input the f of 1, I get 1 squared minus 1 over 1 minus 1. In this case, I have 0 over 0. So therefore, my function does not exist because it would be undefined at the point where x is 1. Now, although the function does not exist, we can see what happens the closer we get to this function. So let's go graph this function. Well, how do we graph it? Well, we can graph it by simplifying this function, right? We can take this, the perfect squares. So it's going to be x plus 1, x minus 1 over x minus 1. We can simplify. Then we have the f of x is equal to x plus 1. Simple linear equation. And we have 1, go 1 up, 1 right. And there we go. We have a simple function. Now, somewhere within this function, there's a point that's undefined. There's a point that's undefined. Oh, I just butchered that spelling, but it's okay. It's a point that's undefined, okay? So how can we find this point? Well, we know we have some limit where if we try insert a 1 in here, the function does not exist. So now we can use the concept of limits. So the limit as x approaches 1. Now, first things first, you never want to direct substitute, okay? Direct substitute means you never want to put this 1 just directly into the equation. You first want to see if it is factorable, meaning can you break it up? X minus 1. So yes, I can. I just did it a little bit earlier. So the limit as x approaches 1, I can break this up to say x minus 1, x plus 1 over x minus 1. I can simplify, and therefore, after I've in its least or its smallest simplified form, now I can substitute 1 plus 1 is equal to 2. So the limit of this function is 2. So where x is 1 and y is 2, at this point, we have our limit. So the function at that point does not exist. Okay. So as we approach, I'm not sure if you guys can hear that, but people's having a party outside and they're whacking bottles on the table. Anyway, so let's do the exact same thing over here. We can see, well, if I put in a 3, my function does not exist as the denominator, right? So let's go find the limit. So the limit as x approaches 3 is going to be x minus 3, x plus 3 over x minus 3. We can simplify. We can direct substitute a 3 plus 3. So the function of this, the limit of this function. I'm so sorry, man. There's some people throwing stuff outside and it's distracting because I can understand what they say. So this one's 6. So if we had to go graph this function, well, we can graph it like this. Again, perfect square. So we can simplify this by saying x minus 3 x plus 3 over x minus 3. We can simplify, and we have the f of x, which is equal to x plus 3. Very simple gradient intercept form. So now we can go graph our coordinate plane, or our system, our x and y system. We start at 3, go 1 up, 1 right. And where my x is 6, my x is 3, and my y is 6 at this point, my function does not exist. Okay, my function does not exist. But I can still see what happens closer I get to this point. So for instance, 5.9999 exists on the function. We can input this as my x value. So I can input this into the equation. I can see what happens to my y. But as soon as I try input, what am I saying, man? Excuse me. 2.9999 2.9999. So I can input my 2.99 and I can see what happens the closer as I approach 3. But if I put in 3, my function would be undefined. So this is the basic concept of limits, and this is how you can solve some of the basic limits until we get to some theorems and more complicated examples. Like I mentioned before, there was some people throwing stuff outside and a big commotion, you know. So I'm going to quickly input this function. So I want to show you the two functions that we just figured out. So the red one is x squared minus 1 over x minus 1. So if we look, in this case, this is what's happening. Look, look, look. We're approaching that limit, you know. We said our limit is 2, right? We calculated the limit of this function. So look what happens when we approach 2. Where's 2? 2 is over here. Okay, so we can see 2 on the y-axis. Look, look, look. So my x is 1. Look, look, look. Oh, as soon as we approach it, boom. Oh. Boom. Look at that. Undefined. Oh my goodness gracious. Okay, but we can still see what's happening as closer we get to this point. Look, look, look. Boom. Undefined. So now we know the limit of this function is 2, which is undefined at that point, but we can see what happens when we get closer to it. Let me insert the next one. The next one, we said the limit is 6. So 6 is over here. Let's go all the way to 6. Where's 6? Okay, 6 is going to be up here. Okay. All right, look. We're going. And boom. At 3, the function's undefined. Why is that? Because if for a simple equation, I'll quickly run over this concept again. I was laughing too much in the previous one. But it's funny, man. You know, people throwing things outside. I mean, it's not funny, of course. We don't want to promote any violence, but you know, anyway. So when we had this thing, the reason it's undefined is since I want to input the f of 3, this is simply going to give me 9 minus 9 over 3 minus 3. The top part's not really that important. The bottom part is what we should focus on. The bottom part is the undefined part, which just simply means I'm not allowed to divide by 0. Why is that? Because if I have nothing, I cannot take anything out of nothing. You understand? Let's say we have like an empty space in time, or some emptiness. Let's say our hand is completely empty. Now all of a sudden I take a 1 out of my hand. Obviously it's impossible. So we cannot divide by 0. Anyway, that's a basic introduction. Good luck.